Hello and good day. In this AWS Solutions Architect Associate, I'll be focusing on this module 6. This is creating a network environment. So I will also go through this challenge lab, that is creating a network VPC networking environment for the Café. So I already initiated this lab. You can see I also started this lab, and this is my console. What the task is, we have several challenges in this, creating a VPC networking environment for the Café. You see, these are the following things which we should be able to do this in this lab. Create a VPC environment that enables you to securely connect to the private resources, enable your private resources to connect to the internet, and create an additional layer of security to your VPC to control traffic to and fro from private resources. So these are all the elements which we should do. Let us go straight to the challenge 1, that we need to allow, create a VPC network. We will be creating a public VPC network that allows Café to remotely and securely administer the web application server. So task 1 is let me open this AWS console, and this is my AWS console. I also duplicate this one. So I go to VPC in this particular screen. So just let us explore what all we require. So already the VPC lab VPC was created for you. You can see that once the dashboard opens. Yeah, this is your VPC. You see that lab VPC is created with the 10.00/16. We were asked to create a public subnet. You see this in under lab VPC with the following CADR. So you see this, the CADR is 10.00/24. That is the subnet which we are going to create. So here I just say subnet. There are no subnets created. Create a subnet. So select the lab VPC and give the subnet name as public subnet. So availability zone, I think he has not preferred anything. Of course, the first one, A, is needed. Okay, the first one, A. So the CADR block is 10.0.0.0/24. So this should be the first public subnet CADR, and yes, create a subnet and create the subnet. So yes, the task number 7 is complete. And also we are supposed to create an internet gateway and attach to lab VPC, that is point number 8. So yes, I am creating this internet gateway. Just create the internet gateway. What's the name given? He has not mentioned anything. I'll say IGW, and IGW is the name tag which we have given to the internet gateway. Yes, it is created. You can see that there is one internet gateway, but which is detached now. We need to attach to our lab VPC cloud. Yeah, I attached this. This completes point number 8. So now edit the route table. Okay, so we need to select and attach to the internet gateway. So how to do that? Go to the route table. Okay, so you can select the router which is connected to lab VPC. Yes, this is the one. Select that. Maybe you can say the routes, or you can even give a name to this one if it is, because we are selecting this internet gateway. I'll give this name as maybe a public route table. Public route table. Okay, so say route, you have only a local route. I need to add a route that is 000. Any traffic coming from the internet gateway, yeah, needs to be routed through the newly created internet gateway which is attached to the VPC. Yes, the route is now added. You can see this, point number 9 is done. So this completes our task 1. Let us go to task 2. So here he has mentioned to create a bastion host. So I will take this as EC2. Here EC2, I'll create a server which is as per the instructions given. So, in the public subnet lab VPC, I need to create a Linux server. The name should be Bastion host. You see this one, Bastion host. I create this, I launch an instance. This is task number 2, a Linux server, Bastion host. Yeah, you can select this as Amazon Linux host. Instance type should be, you can see what is the instance type. He mentioned ST2 micro, we will leave it as it is. And key pair, yeah, you can select walk key. He has mentioned already, you can select this walk key, right. So, the most important is our network settings. So, here select lab VPC and also select public subnet, and auto assign public IP should be disabled. Auto assign public IP should be disabled. Yes, I did that. And security group, what did he say? Security group called as Bastion host 5G needs to be, that allows. So, you can create, I think, Bastion host 5G. Let me see whether it is there or not in your security group. If I say existing one, do I have any? Say no, we don't have. So, let me create this Bastion security group. I will say this Bastion, and also the same thing, the description. So, what did he say? So, he said SSH 2 and my IP. So, here SSH, yeah, source IP is my IP. Yeah, that's enough. Okay, add security group rule. No, this is enough. This is enough. So, we will create SSH. Yeah, I think rest all things are default. The storage is 8 GB. This is okay, and launch an instance. So, this should create an instance very soon. So, I have created an instance, I have launched an instance with the following parameters. Yeah, it is successful. You can also view all instances. So, this completes the task number 2. Now, let us focus on to the elastic IP. You see this, there is no public IP given here. Okay, coming to the task 3, allocating an elastic IP for the Bastion host. So, the task is elastic IP we need to create and attach to this particular, for this Bastion host. So, how do I do that? The task number 3, just go over in the navigation pane, click this elastic IP, okay, and allocate an elastic IP. So, in I think in our US1, yeah, pool of IP address, and say allocate. So, you will be given one fixed public IP. Yeah. So, this I need to associate this elastic IP with our Bastion host, which we have created, yeah, to the instance, and say associate. So, now once this is done, you should get instance a public fixed IP 52 dot. You can check a public IP should be allocated. Yeah, this is your public IP. So, this completes our task number 3. Now, testing the connection to the Bastion environment. So, how do we do that? Okay, you can download the key, SSH key. So, once after downloading the key, you can also connect using this putty. This is task number 4. So, I open this putty, just say run, and we need a key file. So, key is available not here, in under details. You should see AWS show can click show. Yeah, so download this ppk. This is public private key. Okay, I think this is enough. So I'll so this is task number 4 I'm doing. Yeah, so what did he mention? Download the ppk or and then connect using SSH. So already I have this putty, I'm connecting using SSH. I also provide this key file, lab user, and say open. The username by default it is ec2-user. Yeah, successfully I am able to complete login to task number 4. Yes, you can see this. So this is enough. Task number 5, go back to your VPC and create this task 5, that is create a private subnet. Okay, so I go back to the VPC. Yeah, again I go to the subnets. In task 6, create a private subnet. That should be same with under lab VPC only. So create a subnet. Yeah, the VPC ID is so and so. Yes, lab VPC. The name of the subnet is private subnet, and the preference is given as availability zone, same as public subnet. That is 1A. That is 1A. We have chosen that, and the CIDR which is recommended is 10.0.10/24. 10.0.10/24. Yes, so I'm almost, the private subnet is now ready. Yeah, task 5 is complete. Task 6, creating a NAT gateway. So we are going to create a NAT gateway which will communicate from private subnet to the internet. So here I'm going to use this. Yeah, go to your NAT gateway. Yeah, NAT gateway. So here create a NAT gateway, give the name as optional lab NAT gateway, and select this public subnet. Okay, subnet is public subnet. So I have public subnet and private subnet. Yeah, and needs an elastic IP address. So create a, so your NAT gateway needs an elastic IP address. So what I do here, allocate public elastic IP. No elastic, so elastic allocate. So it has allocated one more elastic IP. Yes, in additional settings, nothing is required. Check this particular one. Right, your okay, and create a NAT gateway. This should take a minute's time for us to create and available. You see here the NAT gateway is about to get ready. Yeah, so now also he asked us to modify this private subnet to connect to this what we call as route table. So for this what I am going to do, I am going to create a route table which is attached to, I will say as private route table. VPC I am going to select as lab VPC, and I create a route table. Yes, I do have public route table which is the system, yeah, earlier which I have connected to internet gateway. Now I am selecting this private route table, add my route. So I don't have any route, I edit this route and I connect to the NAT gateway. So here I select NAT gateway, and I have already created this NAT gateway. I am going to route through this NAT gateway. Yes, this is submitted. Okay, so yes, this is this completes your task number 6. Task number 7, creating an EC2 instance in the private subnet. So what we are going to do with all the basics which is there, so the name of the instance is private instance which doesn't have any public IP. So again I take this particular one to the EC2 instance. Okay, create another instance, launch instance. So I give this instance as private instance. So select this Amazon Linux. Okay, The instance what is recommended is T2 micro, I believe, T2 micro, and it should have private instance should have uh, the walkie2 create a new key pair called as walkie2 and download the appropriate APK, right, and also it should be allowed so and so, and it should be in private subnet. Okay, so how should I go? This key pair, I need to create a new key pair. The key pair name I can give as walk key pair 2. Yeah, walk key 2, and download the necessary one. So I need ppk, okay, and download appropriate ppk, Microsoft Windows or PEM key for Linux. So I need PEM key. Okay, create a key pair. Yeah, PEM is downloaded. So for our network, I think I need to download this ppk key, but it's okay. I can convert this key using yeah, you can see this walk key. For Microsoft Windows I need appropriate ppk key. So I create a new key pair which is called as walkie2, and download your ppk key, not the PEM key, ppk. PEM will be used for if you are using Linux machine or maybe a Mac machine. I am using Windows, so I need this ppk key. So create a new key pair. Yeah, I have downloaded this walkie.ppk2. Yeah, in network, please go through this edit settings, select your lab VPC, and under this select this private subnet only. Yeah, you can see here private subnet. So see that Bastion host, my security group, the security group's SSH port to 22 is required, and so source is Bastion group, security group is only allowed. So here you see this. Yeah, you can create a security. You can see what are all the security groups which are there. Bastion's host SG which is there. So this should allow port number 22, Bastion host security group. So I'm using that. Otherwise I can create a security group uh, with a different name or anything, and what I can do in source type, I can say custom and provide sources SG Bastion host. Okay, this way also I can go, and that's all. Configure your storage, advanced details, launch instance. So this completes my task number 7. So configuring your SSH client for SSH pass through. So for Microsoft Windows users only, please follow this one. So download and install Pagent. So here this is your download page. Open a new window. So please follow the instructions very clearly. So here download this Pagent. See this one? Yeah, this one. This is 64-bit. So I download this and run this. It will be run. So it will be there in your memory like this. Agent. Okay, go back. Add the key. We need to add the key. Select the ppk key. So here this particular one, I am going to add the key. Add key. I need to select the walkie2, right. So it has successfully added. How do you know whether it has been added or not? You can see here, view the keys. You should see one key like this walk key has been added. Okay, so now add the key to the lab user. Should have two add the first work key also you downloaded earlier. The name was labuser.asterisk. The file name was labuser.asterisk. The key also, the second key I need to add. So first I have added that. So the second key also needed, right? This particular one, where is that? Yeah. See, add a key. This particular one lab user, which is also. So I have two keys here. CPU keys. There are two keys here, walk key and the other one. Just say close. So now add the walk key you have downloaded earlier. The file name is lab user. Should have two keys listed. 27 is over. Now in putty under connection SSH, okay, allow agent forwarding. So what I do here, you see this. This is my putty which already I have logged in earlier. Okay, so I'll minimize this. So once again I open this putty, just say run with the following parameters. So connection SSH auth, select this agent forwarding also, select agent forwarding, and also expand your auth credentials, and select your private key file key for authentication. Under credentials, see this private key file credentials, lab user ppk, the first one which you have downloaded. Okay, and you can, what you can do is yeah, open and choose accept. So file, okay, so select this session and give this file. So this is my what we call instance. So I have now two instances, Bastion host and private instance. So in your private instance you don't have this public IP, you don't have this public IP, you have only private IP. So I select this. Okay, go to the instructions very clearly. Yeah, and so open EC2 hyphen user. Yeah, I have logged into the Bastion server, and then see here, accepted, you have completed this step. Task 9 to step 32, proceed to the Bastion host using putty unormal, but you don't open a ppk file. Okay, so this part is done. Testing SSH connection from so and so. So what I do now is SSH EC2 user at the rate of private IP. So yeah, my private IP is yeah, this is my private IP 10.01.164. Okay, so you see here SSH EC2 user, very important step here, SSH EC2 hyphen user at the rate of your private IP. Yeah, yes, this you should be able to connect successfully to your private server. Yes, I am able to connect to my private server from my Bastion server. This agent, remember, this agent needs to have the keys, both the keys. If you don't, you will not be able to do that. Okay, now try to ping maybe the gateway server, ping 8888 or google.com or anything. You should be able to. Okay, Control C, test the internet connection. Maybe I'll try to do in this way, ping www amazon.com. Yeah, no, it's trying to translate. Maybe ICMP is not allowed, hence that is the reason why you are able to not able to communicate. You have established communication between bastion host and EC2, yes, in the following diagram. So now we have a challenge 2, enhancing security layer for private resources. So what we need to do, we will create a network ACL. So in Amazon VPC console, again I go back to VPC console, yeah, inspect the default VPC, that is lab VPC. So here, yeah, we already did that. We already default network ACL of lab VPC. So go to network ACL. This is security network ACL. So you have two subnets. This is of lab VPC. You see this one? Yeah. This is network ACL ID. Let us check this inbound rules. You have everything allow, all allow network ACL. You see this? So all traffic 0000 is allowed. Create a custom network ACL called as lab network ACL for lab VPC. We want to create a new custom ACL. The default inbound and outbound rule of the custom network ACL should deny all the traffic. Inbound and outbound rules of the custom network ACL deny all traffic. Okay, so let me create a network ACL. Create a network ACL. So the name is lab network ACL. Select my lab VPC. So I create, yeah, select this ACL, and what he has mentioned is inbound default is all is deny, all is deny, and your outbound all is deny, all is deny. Okay, so I have created your inbound and outbound for this lab. Configure your custom network to allow all traffic from the private subnet. So let me do that. So to allow all traffic that goes into and out, so let me go to the inbound and edit inbound rules, add a new rule. You can say rule number anything 100, all traffic allow. Yes, I am making a change, save. Yes, so also outbound traffic, edit inbound traffic, outbound traffic, add a rule, maybe you can say 100, all traffic allow, and say save changes. Yes, the rules has been created. Now testing. 10th one is over. 11th one. So create an EC2 instance in a public subnet with lab VPC that should meet the criteria. So let me create one more instance. Here I go back, actions, launch an instance. So the instance name is test instance, test instance. Okay, select your Linux, T2 micro. The key pair should be, didn't mention any key pair. I will take it as walk key. Only we are going to test this ping. I'll test this, I'll use this walk key, right? And also I need to select this lab VPC, okay, and public subnet, yes, public subnet, it should meet the following criteria. So allow all ICMP inbound traffic to the security group. Scroll down, create a security group, okay, you can use this, and also I will allow, so I'll add a new rule. Where is that rule? Add security group rule, allow all ICMP, all ICMP before port range, custom type anywhere. Yeah, I'm adding that. So this is the challenge which he has given. Yeah, note the private address of the test instance. So ping to the private address. So Once this is done, I will create this instance. So this should be ready. Once this is ready, note the private IP of the test instance. Yeah, this is my test instance. What I do, I have this private IP 10.0.0.196. I need to do a ping test. Okay, so I do what I do is ping. I think I need to come out and do a ping, because I have allowed ICMP both should be there in the same subnet. Yes, I am able to do a ping. Leave the ping utility running. Okay, modify your custom network ACL to deny all IPv4 traffic. So make sure, so that is in deny all ICMP traffic to private IP address of the custom ACL. Okay, network ACL. So I have this ACL. Okay, I go to this inbound rules. So what I need to do is that custom network ACL to deny all traffic. I will add one more rule, private IP of the test. I will deny that. So in inbound, I will say add a rule, edit inbound rules, add a new rule, maybe I will say 101, okay, and say deny all ICMP4. This is deny the source IP, okay. So if I say like this, okay, so automatically, yeah, you should see this to the private subnet. I mentioned, I missed that, private IP of this particular test instance. Edit, not this particular one. I should give this private IP 10.196/32. See this /32 at the end of private IP. Make sure that this is the rule evaluated first. In private instance, the ping command should stop responding. Okay, when I say save, so once this is ping is stopped, yes, you can also verify that there are some questions which are there. We need to answer these questions, so 6 questions which are there. So yeah, try to refresh for your questions. In details, just a show for your URL. Yeah, these are the questions. What is the purpose of internet gateway in the public subnet? So you can see allows instances in the public subnet with a public IP to communicate the internet. Okay, let me submit. Right. Second question, what allows the instance in the private subnet to connect the internet so that it can download updates? That is the NAT gateway. Just you submit. Okay, can the instance in the private subnet be accessed directly from the internet? I think it is no. Yeah, let me submit no. So the fourth one, why do you use 2 different key pairs to access private instance and bastion host? a separate key pair should help reduce the impact of compromised bastion host. Yes, that is perfect. I say submit. The fifth one, can the bastion host use ping command and get a reply from the instance in the private subnet? I think it is no. Yes, just say submit this one. And sixth one is, which security group rules allow the private EC2 to receive the return traffic when it pings the test instance? This is outbound on private and inbound on test. This is the one. So I select this and I say submit. Your sixth question is done. So once this is done, I think what you can do, we are almost at the last, we can just say submit. I think we missed out only the last. Yes, we completed. Yeah, we can submit and we can see our score. Yeah, just say yes. Yeah, we have a score of about 46. I think there is some error in the network ACL. Other than that, my lab is totally correct. Yeah, we have a lab VPC as a private route table also. I don't know why this is coming like this, but otherwise this is correct. Thank you. We'll meet again in a different lab. Thank you everyone and bye.